Hey everyone, in this video we're going to discuss the real number system and some of the types of numbers that come into that system and how you tell them apart. So what I want you guys to think is, if you've ever seen those Russian nesting dolls, those are the ones that when you open up a doll, there's another smaller doll inside. You can open up that one and there's another smaller doll inside. That's kind of the way numbers work. There's the smallest set of numbers that opens up to a bigger set, that opens up to a bigger set. And in the long run, they all end up as real numbers. Okay, so that's our end goal. A real number is just about any number that you can look at, with the exception of imaginary numbers. And depending on where you are in this course, you may or may not have seen those yet. But that's where real numbers fall. So I want to start with the smallest set. And the smallest set of numbers are what are called the natural numbers. And the natural numbers are your counting numbers. So when you start counting something, you're going to start at 1. So you'd go 1, 2, 3, etc. So those are your natural numbers. Now, shorthand for naturals is just the letter N. Okay? So those are natural numbers. Whole numbers is the next set. And whole numbers contain all of your naturals, but they also contain the number 0. So instead of starting at 1, we start at the number 0, and we go from there. Now, most of the time you'll see whole numbers denoted by the letter W. Now you carry that on to integers. Now what integers are the naturals and their opposites. Okay, so you've got the naturals and the opposites. Now because these things build up, 0 is also in the integers. Okay, it just doesn't have an opposite. And when I talk about opposites, I mean negatives. Okay, so we're looking at the naturals, which are 1, 2, 3s. But we also have the negatives, which are -3, -2, -1. Remember, 0 is in there, 1, 2, 3, and so on. And the integers are usually denoted by the letter Z. So if you see the letter Z, those are the integers. The next group is the rationals. And the rationals contain all of these we've already talked about, plus anything that can be written as a fraction. Now, if you think about, just the number 7, for example, could you write 7 as a fraction? The answer is yes. It's 7 over 1. So 7 is considered rational. But also, 3 halves is considered rational because I can write it as a fraction. Now, let's think of the number 1.5. Is that rational? Well, you have to ask yourself, could I write that as a fraction? And again, the answer is yes, because 1.5 is just 3 halves. Okay, so those are rationals, anything written as a fraction. Now, there's a few shortcuts that you can think of these. Different types of decimals, we call them terminating decimals. So terminating decimals are decimals that have a stop at some point. Those could always be written as fractions, so those are considered rationals. The other ones are repeating decimals. If you have a decimal that repeats, could be written as a fraction. Okay, so those are all considered rationals. Rationals are given by the letter Q. Now, the other one that's kind of off on its own, as you can see here in the notes, is what's called the irrational numbers. Now, the irrational numbers are anything that's not rational. So we're talking decimals that don't end, decimals that don't repeat. So think never-ending decimals. And I'm sure that you guys can think of one never-ending decimal. It starts out 3.14 or the number pi. Pi is an irrational number. It goes on forever without ever repeating. And there's plenty of other examples. Now, other ones that you guys will run into are numbers that are square roots of non-perfect squares. Okay, so I'll put that up here. Square roots of non-perfect squares. And if you put these in your calculators, you'll see that that number ends. And the only reason it ends is because your calculator only has so many places. Okay, it can't go on forever. But if you did like the square root of 25, that answer is 5. If you did the square root of 26, you're going to get 5 point and then a bunch of decimals. Those decimals would never end, therefore it is irrational. Okay? And sometimes you'll just see irrationals with an IRR just to denote that they are irrational. All right, so those are your number sets. Give your assignment a try, and let me know if you have questions.